All right. So what we have today, as soon as I unfreeze the board and get everything set up, let me take a little sip of my tea.
No.
All right. What we have today is your favorite assignment, the explorations. The reading is assigned, so go ahead and click on the exploration reading, which will take you to the section that we're working in, which is Metamorphic rocks. We all right over there?
We got a free day today.
It's cold. Yeah.
So we're in Metamorphic rocks. We're at the top of the section here, and so just scroll back up just a little bit so you can see the menu. Click on Explore More Resources, as we usually do, and then scroll down to the bottom of Explore More Resources, all the way down to the bottom, and find the green exploration box that says Metamorphic Rocks. That is our assignment for today. Let's make this big screen. We're going to have to do a little bit of work with the exploration today because they do ask us some questions about this. We want to see some microscope slides. And actually, something we're about to see is maybe, well, we'll see. Maybe not. Yes. Oh, you don't have it? Hold on 1 second and let me get that open up for you. Let me go back in here. I thought I changed it. But we did it.
Mine didn't show there either. I just went to the assignments that was there. But
Let's see.
I think we have a plan this
Let me
summer.
come back. What's that? Quit impersonation. And go back to the assignments. And
Interesting conversations.
text.
Impersonation.
Oh, right. It says y'all have already completed it. Then let me just assign a new one instead of this one. So delete that. Unassign. Yes, I have to impersonate people. That's why I created a generic student account, so I wasn't actually impersonating any of y'all. Seems like something
Well, I think you should use your own.
because mine has different.
This is a teacher.
Yeah, it's got different menus and like it'll do things like show me all the answers.
oh, you should definitely use those.
Well, I know.
No, I feel like
Most of
you
them.
should give us that one.
No.
You can have all of
We
ours.
can impersonate you.
No.
You can
Sounds like
impersonate us.
So let me just reassign this and then we'll all be good to go. So that's just going to be for today. Because tomorrow we'll start on something new. We're also excited. Okay, so now reload your page and you should be able to see it now.
And then I was just like,
Yes, the reading, yes.
Scaled or like from you to Emma and everyone else.
All students, yeah. If you're already on the page, you're good. You don't have to go back and find it. But for those that had a hard time seeing it, it should be good now. And if it's not, let me know. I think everybody should be able to see it now. So that made for the most boring 5 minutes of this video, but they'll have to deal with it. If you were in class, I don't even know if I have. I guess I do have some remote people. Julian.
No, it's almost Friday.
So now that you have the reading, go ahead and click on the reading. It'll take you to the Metamorphic Rocks section of Discovery Education. Scroll up just a little bit where you can see the menu, and you'll want to click on Explore More Resources. They go a little heavy-handed with that. We're in the Explore tab, Explore More Resources tab, and then we go all the way down at the bottom to find the exploration. We're like triple exploring. So make sure you click on the green one that says Explorations, Metamorphic Rocks. And you'll know you have the right one because if you scroll down just a little bit after everything pops up, you should have some answer boxes that you can put answers into, which is why we use this. Instead of printing them out and having them where I have to grade them by hand, we can grade them on the computer, and it's a lot easier. So, like I said, we're going to look through some rocks in microscope view, and we're not really there yet. Maybe, I guess it probably would have come in during igneous rocks. One of the coolest things I learned in geology was that you can cut a rock thin enough that light passes through it and you can see it in a microscope with actually light shining through it. And it looks like a kaleidoscope. It's actually one of the coolest things in nature that I've seen. When you turn a kaleidoscope, you have all the colors popping in and out and things moving around. And that's very much what you see when you see a rock in thin section. I don't know that they're going to show us thin sections today, but we'll see what they have. So let's try to work through this pretty quickly so we can use this information to help us answer some of the questions. So what do they want to do here? We need to metamorphose some rock. So we need to put some parent rock in here. We need to put some metamorphic rock in here. And I don't know what we need to do with it. Let's give it a try. So let's add some coal. What's coal going to turn into? It's going to turn into a different type of coal, which is going to be this anthracite. So we add that, and then I guess we're going to check it. I think this is going to be foliated. And metamorphism, I'm thinking it's going to be, for coal, regional metamorphism, probably. Oh, do I got to give a microscope view too? Oh, I see. Wait, hold on. But that's maybe not what I wanted to do. No, you're good. You're good. I should have used very fine. There we go. So I'm going to add that. So notice all my samples here are dark colored. So I go from a black colored coal to an anthracite that's very black. And then I go in the microscopic view and it's all black and it's very fine. The only thing I'm unsure about is whether this is going to be regional or contact. I'm thinking regional because we find coal seams over very large places, but let's see. No, I got both those wrong apparently. So it's going to be contact.
No, it's both of them. The first one.
Oh, regional and contact. And I have to add all my stuff back in. Well, we're not using slate. We're back here in anthracite, and we're all the way over here at very fine. And it's what, both?
No, it's both.
Yeah, non-foliated, because I can't select both of those. All right. Nice. I like how y'all are all yelling at me like you know it, but you really just tried to answer early.
Yep.
Yeah, I know what y'all doing. It's okay. I appreciate the help, though. So we got that one. What? Contact metamorphism, regional metamorphism. I don't know what they want me to do. So they're just going to show you here. This is contact metamorphism. If I'm near some hot lava, I can get like a band of metamorphic rock that gets heated up and metamorphosed. But if I'm too far away from that hot lava, I'm not going to get the metamorphic rock because I just didn't get that heat over there. But regional, I'm going to have a large area. I'm going to have two plate tectonic plates smashing into each other. And when they do, they're going to create a huge area of metamorphic rock, usually like in the center of the mountain range. That's going to be my main part of my metamorphic region. So I guess that's it for that one. Now what? Just reset? Do I do all these? This sounds terrible. So limestone is going to turn into marble. Notice here my colors are matching up. My light-colored limestone is a light-colored marble. I'm guessing it's probably going to be medium to coarse. Can I not select this one? I guess I can. Very fine. Medium to coarse. I think it's going to be this one. Medium to coarse, 6 of 7. It looks like the rocks that I've selected here. Marble, I think, is definitely going to be regional. Could be both, technically. It's definitely non-foliated. It is both. It's fine. Could be both. Check. Yes, we're good. They're going to show you the contact. These are all going to be the same for the contact and the regional. Okay. So, reset. What's number 3? Mudstone. Mudstone is going to turn into what we call slate. If I can find it. Is the first one? There we go. Slate. And slate is going to be probably like a very fine. Let me guess, very fine. Regional, contact. This is going to be foliated, so I'm guessing it's not contact, and it's just regional because contact isn't really going to have the pressure to make it foliated, and I was correct. Wonderful for me. So let's reset this and do number 3. Quartz sandstone is going to form quartzite, which should be large grained, or like a medium to coarse. It's not very fine. I'm going to try this one, even though we've already used it. And this could be contact or regional. It's going to be non-foliated. Am I right? No. Which one's it going to be? That's not it. Number 4? That doesn't look like it. That's fine. I understand. It's medium to coarse, but that's for granite and not a quartzite. But I'll let it slide. That's fine. Okay, then reset. Now what? Slate. Slate is going to turn into phyllite. This is going to be kind of like a shiny looking one. So let's see. Maybe not very fine. Maybe just fine here. I think that should be good. And this is going to be regional only because it's foliated. It's got some flat spots, so it needs the squeezing along with the heat. And let's see what else we got. Schist. No, slate. Slate I did to phyllite. Schist will turn into gneiss. Schist will turn into gneiss. And probably going to be this medium to coarse here, I assume. It's going to be foliated. It's going to be regional. Is that one going to be wrong?
It's the first one.
The first one.
Medium to coarse.
Yeah, you can see the foliations here. That makes sense. You can see the lines, just like you can see the lines in this rock. Fair enough. So we got that. Reset. And is that it? Phyllite. Phyllite will turn into schist. And that will be not the very fine, maybe this medium to coarse, I'm assuming. Foliated, regional. Check. Yeah, nice. Okay, that should be all of them. Go to the tracker. Continue. Nice. That looks like all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I think we're good. They got a couple that are doubled up for regional metamorphic. Nice. So we might need to come back this to answer a couple of the questions in the actual exploration. So what do we got? We got 10 questions. Make sure you answer all the questions and hit submit at the end. Let's go through them one by one. Number 1, describe the 2 main causes of metamorphism. Explain their role in the formation of metamorphic rocks. What are the 2 main causes of metamorphism? What's the other one?
Heat.
Yeah, heat and pressure. Pressure and heat. Explain their role in the formation of metamorphic rocks. Heat is going to get the rock up to almost melting. And pressure is going to realign the minerals and possibly give me some foliations. So heat and pressure. Heat is going to bring the temperature of the rock to almost melting. Got to make sure you say almost melting. And pressure is going to rearrange my atoms or my mineral grains to all be aligned in foliations. I'm going to get foliations out of it. Pressure will give me foliations. Okay, number 2. Compare contact metamorphism with regional metamorphism. How are they similar? How are they different? So, contact metamorphism is going to be caused by heat due to being right next to lava or magma. Literally touching lava or magma. So, contact metamorphism is caused by extra heat for rocks that are in contact with magma or lava. So they're touching the magma or the lava. Hello? He's absent today. All right, no problem. All right. Yeah, you can use it. Go ahead. So yes, we got the contact metamorphism is caused by heat, and it's when it comes in contact with lava or magma. Regional metamorphism is caused by pressure from two tectonic plates squeezing together. So regional metamorphism is caused by pressure from two tectonic plates squeezing together. That should be good enough. Number 3, compare the microscope views of the rocks that form through regional metamorphism only with those that can form through contact metamorphism. What differences do you see? How do you think these differences relate to the types of metamorphism the rocks have experienced? So if we go back up here, they're asking us, what do we see in the difference for our microscope rocks between regional metamorphism and contact metamorphism? So if we come back up here real quick, I don't know if we'll be able to see. We can't click on this or see this. Yes, we can. All right. So look at the differences here. For ones that were regional versus contact or regional, if I look at the contact regional, I get pictures that are very much the same all the way through. So obviously this is just all black. If I go to the next contact, it's mostly all white. I do have a couple chunks of different minerals in here, but there's no patterns. There's no lines. There's no stripes or anything like that. It's just one solid thing. If I go down a little bit more, I get a little bit more of the same. I get a little bit more of the same. I got some different stuff going on here, but there's no patterns. There's no lines. There's nothing like that. Now, if I go to the ones that are only regional and start to look at those, obviously this one's very fine. It's not going to show anything. But in this regional, I start to see some lines. You can see this black line. You can see this white line. It's still a lot of fuzzy stuff, but it's not quite as mixed up. And then as I continue to go down the list, I'm going to see more and more lines. So you can see the squiggly lines in here. Where's the next one? That's not it. Here we go. You can see some bigger color lines. I got this big, thick line of like blue and gray with some black on either side of it. And what's the last one look like? Even more lines right here. And so what do we see in the microscope views of rocks from regional rocks and contact metamorphic rocks? So what differences do we see? We see that the regional metamorphic rocks have more linear or more line features. So you can see the foliations, you can see the different layers, you can see the lines. So regional rocks have more line features or more things that are lined up, where your contact rocks don't have any line features or stripe features or anything like that. They're just like a plain rock, kind of. And how do you think these differences relate to the types of metamorphic rocks or metamorphism rocks have experienced? It's all about pressure. If the rock has been squeezed with pressure, it's going to have those lines. It's going to have those linear features, those foliations. If the rock wasn't squeezed with pressure, then everything's just going to be the same in any direction that you look. You're not going to have any lines. You're not going to have any foliations. And so that's what that means. So just to recap, your regional metamorphic rocks have the lineations. They have the lines. They have the foliations. Your contact metamorphic rocks do not. How does that relate to how they formed? It's all about the pressure. The regional rocks that have the lines or the foliations had pressure. The contact rocks did not, so they don't have any of the lines or foliations. Wonderful. Number 4. Geologist mapping a mountain range finds a foliated metamorphic rock formation exhibiting compositional banding with distinct light and dark bands. What type of rock is this likely to be? What does its presence tell the geologist about the geologic history of the mountain range? Explain your inferences. All right, so this is a little bit advanced, but we can go up here and look at this. We're looking for a rock that has light and dark bands. And so if we go back through these, and look at, actually we were looking for metamorphic rocks. We're looking for the rock that has the light and dark bands. You can easily find one pretty quickly. That's your gneiss, Gneiss. And so what that guy has found is a piece of gneiss. And what that tells you is, if we were to look this up, we'd say that it has regional metamorphism, right? Because I see the lines, I see the flat things. These are my foliations. And so I know it's been squeezed. Because if it wasn't squeezed, I didn't have these lines. And so it's foliated, and I know it's regional metamorphism. So let's turn that into an answer. So what they want to know is, they have this geologist, he's mapping a mountain range, he finds some foliated metamorphic rocks showing this light and dark bands. What type of rock is this likely to be? This is likely to be a gneiss, Gneiss, gneiss. And what does its presence tell the geologist about the geologic history of the mountain range? It tells the geologist that this rock formed under high pressure and high heat, which means it's a high metamorphic grade. So the rock type is gneiss. It tells the geologist that that mountain range formed under high pressure, high heat, and has a high metamorphic grade. So that rock has been really metamorphosed. Not just a little bit, but a lot. It's been changed from a little boy to a cockroach. Missed the inside joke. Yeah.
How's the word say again for the rock? Nice.
Nice. Yes. Gneiss. Nice. It's the G is silent. Right? Yeah. Gneiss. Nice. Good nice. Okay. Number 5. Can a parent rock itself be a product of metamorphism? Back up your response with evidence and reasoning. So you better bring your evidence folder and submit it on this one. No. Can a metamorphic rock be a parent rock to another metamorphic rock? What does it take to be a metamorphic rock? What do we need? Heat and pressure. And can I apply heat and pressure to pretty much almost anything? Yeah. So can I take a metamorphic rock and just put more heat and pressure on it and change it to something different? Yes. And that's why I like rock charts like this that have this little loop-de-loop over here near the metamorphic rocks. And so, yes, I can take a metamorphic rock and heat and pressurize it and just make it another metamorphic rock. And we actually saw that in the exploration here. This is not the one I've been doing. Here we are. We actually saw this in the exploration. We come up here. The parent rock, they have listed, like right here, slate is a metamorphic rock. But they have it listed as a parent rock. Schist is a metamorphic rock. They have listed as a parent rock. Phyllite is another metamorphic rock. So yes, obviously I can use heat and pressure on metamorphic rocks to make them more metamorphic. And I guess if you want evidence, just look at the exploration. The exploration has 3 examples of metamorphic rocks that are also parent rocks. So can a parent rock itself be a product of metamorphism? Yes, all it needs is heat and pressure. Don't just write yes. At least write something about heat and pressure. Back up your response with evidence and reasoning. I don't know. Let's tell them that I found a rock cycle chart that shows that metamorphic rocks can be remetamorphosed, and in the exploration it shows me 3 examples: phyllite, schist, phyllite, schist, and slate. Yes, all listed as parent rocks, but are metamorphic rocks. Let's see. I'm going to put some grades in for y'all. Number 6. Compare and contrast the formation of metamorphic rocks with that of igneous and sedimentary rocks. Let's just make this simple. So we're comparing and contrasting. Igneous rocks get fully melted. So I would start off there. Igneous rocks get fully melted. Metamorphic rocks need heat and pressure but do not get fully melted. So igneous rocks get fully melted. Metamorphic rocks need heat and pressure, but do not get fully melted. And then I'll just throw in at the end, sedimentary rocks don't need heat or pressure. You just need sediment and cementation. And that kind of compares and contrasts all of them, doesn't it? I think that does an okay job. I mean, it's not like I'm going to get an essay award or anything, but. So igneous rocks need to be fully melted. Metamorphic rocks need heat and pressure, but are not fully melted. And sedimentary rocks don't need heat or pressure. You just need sediments and cement. You need a little bit of compaction, but it's not really pressure. I mean, it is pressure, but not pressure like metamorphic pressure. Number 7, explain what property makes slate a useful rock. Okay, so slate. Does anybody remember? I spent some time telling you what we use slate for. Yes, houses and roofs. So if I want to make like a roof tile out of slate, what kind of property could it have that's going to make that super easy? Does anybody know what slate does that's different than other things? Let's see. Kind of Google slate, show me some pictures. Because this is a very important property. It's kind of like the whole thing. Slate. What is a slate? Like if I told you we had a slate of something, what would that mean? So look at the pictures. This is a slate roof. These are like roof tiles made out of slate. Here's like a pile of slate. What is this rock doing that other rocks don't do?
It's flat.
Yes, it's flat. And look, like if I had to cut every single shingle flat like that, now you're talking like really, really expensive roof. And so these aren't getting cut flat like that. They're getting cut into squares to make them into shingles, but the top flat part and the bottom flat part are natural.
Slate roof though.
And so you can see here, like this is a regular piece of slate, this is a regular piece of slate. They all have that flat top and bottom. That's what makes slate special. Okay. It has what we call cleavage. Foliations, and so slate will break on flat planes. Slate will break on those foliations or flat planes and make flat-sided pieces of rock.
Why would you want one?
Because once you get it on here, it's going to last forever. Normal composite roofs, you're talking 15 to 25 years, mostly, which is a really long time. You're not going to have to replace your roof too many times in a lifetime if you stay in the whole house. But you can have a lot of, leaking and damage very easily, where slate roofs, regular rain and weather is not going to get to that. Maybe some big hail will crack it, but this is going to be much, much more durable. If you ever go in some of the wealthier parts of Dallas, you see a lot of the roofs have that like red Spanish tile. The like S-shaped tile on the roof. That's the same thing. It's not natural. We make those brick tiles. But once you get them up on the roof, it's really heavy and it's more expensive. But it's going to last like for a long, long time.
Who has? Do you know anybody that is?
No, I know you got some houses in Highland Park that got some slate roofs. To be honest, I'd be extremely surprised to see one in Waxahachie. I don't know that anybody in Waxahachie is a slate roof, but you can definitely see some slate roofs in like Highland Park or some of the nice areas of Dallas, like Preston Hollow and stuff. There's in the rich houses you see slate, but even then, it's got to take someone that really like. You got to be so rich. You're like, I want my roof to flex on my neighbor's roof. Like, just a regular roof is not good enough for me. I need everyone to know that I spent a lot of money on my roof. Or, you go to like different places in Europe might have these. It's still going to be mostly only for rich people. But in places like Europe where you get raw materials pretty easily and the houses are already really, really old, you might be more inclined to put a roof on that's going to last another 80 to 100 years as opposed to just 15 or 20, because your house is going to be there for a long time. So I don't know. It's it's a wealthy thing for sure, but it's not too crazy. It makes sense in your brain. You're like, put something better on there. Did I answer everything? What's the property that makes slate useful? It breaks along foliation planes and it has flat sides. So when it breaks open, it already comes in those nice flat pieces. So I can make my floor out of it, or I can do my countertops or something out of it, or my roof if I want to. So number 8, this exploration covers 2 types of metamorphism: contact and regional. Describe the other types of metamorphism. Like what?
I don't know. I guess we
What?
should skip it.
Contact or regional? What are they talking about? Let's see. No. Now I'm curious. I mean, we're not gonna go like to the ends of the earth to find this answer, but what are the other? I think they maybe just be talking about foliated and non-foliated. Because the contact versus regional, there is no like other type of that. Those are the only 2, and you either fit into one or the other. It's contact or regional. So I'm assuming, that they're talking about foliated and non-foliated, and then maybe the parent rocks. Let me read the question again and see what they want. 2 types of metamorphism: contact and regional. Describe the other types of metamorphism. Yeah, that's just got to be foliated and non-foliated. So just put foliated metamorphism creates features with parallel lines, and non-foliated metamorphism doesn't create any parallel features. That's probably a good way to put it. So foliated metamorphism creates features with parallel lines, and non-foliated metamorphism does not create features with parallel lines. Oh, okay, we can do that. Number 9, list the common constituent minerals of the metamorphic rocks in the exploration. So let's go back up and see if they give us some minerals here. I'm not seeing any minerals. What if we go to our chart? Tracker. Okay, yep, they got minerals here. No, they don't. These are the rock names. Can I click on this? Bituminous coal. Anthracite coal. What do you want from me? Okay, so let's just look at some of the names. That's not going to be great. Let's just put some of them in here. So minerals that we have in these rocks. Let's go back to explore. And these are the metamorphic rocks. So gneiss is going to have quartz, feldspar, and what else? Let's say micas. Quartz, feldspar, micas. There's a rock in here that has calcium carbonate. So marble's a bunch of calcium carbonate. What else? We already said quartz. Anthracite, this is going to be, it's not really a mineral. Yeah, just say coal. Coal can be a mineral. We won't say like plant fragments, but we can say coal. Because coal is a mineral. Nice. Schist, that's going to be a lot of your micas. That should be good. What do we have? What did I tell y'all? What do you have written down?
Quartz, feldspar, micas, calcium carbonate, coal.
Yeah, that'll be fine. 5's good. That'll be good. All right. And number 10, what is the difference between low-grade and high-grade metamorphism? So there's going to be 2 differences between low-grade and high-grade metamorphism. The main difference is how much metamorphism is done. Low-grade metamorphism is going to be just a little bit changed. So remember, with metamorphic rocks, we're changing things. So if I change just a little bit, that's going to be low-grade. Where high-grade metamorphism is, I'm going to change most of the stuff. I'm going to change almost everything until it gets really close to being melted, and then I'm going to stop. But low-grade metamorphism is just a little change. High-grade metamorphism is a lot of change. And the other difference is going to be the temperature and pressure. So low-grade metamorphism is low heat and low pressure. High-grade metamorphism is high heat and high pressure. And that makes sense. The more heat and pressure you have, the more metamorphism you're going to do, or more metamorphizing. Metamorphing? Metamorphosis? I don't know. The more morphing you're going to do. And then the less heat and pressure you have, the less changing you're going to do. Metamorphosing. I think that's it. Okay, so 1 through 10. Anybody need me to repeat anything? If you have any questions, let me know. Make sure you hit submit and get your full credit for this assignment. And tomorrow, we'll start on a new section.